What's up guys, welcome back to the channel. Today on this video we'll be calculating the value of this integral where we're gonna do the definite integral. Alright guys, as you can see, this integral here, it has limits now. It has the upper limit, which is 3, the lower limit, which is 2. Just in case you don't understand the definite integral, I made a video about the definite integral, the intro in fact, so you can go and watch that intro if you really want to understand what is happening here. If you already watched the intro, now it's fine, you can pause this video and you can try to get the answer here. Let's see if your answer is going to be the same as the answer that I'm going to get at the end of this video. Before I start though solving this problem, I'd like to say thank you very much guys for watching, subscribing to the channel, commenting, and also sharing the videos. If you haven't subscribed, subscribe to the channel and also like this video as well. Alright, so before we start solving this problem, just like the indefinite integrals, you need to look at your integral here. Do we need to simplify this? Yes, we do. As you can see, we have a fraction there. We need to get rid of this fraction that you see here. So before we integrate, let's simplify here. So from previous videos on integrals, we know that when we simplify, the sigma and the dt remains there, right? So what you should do, you should divide each term with this t squared there, because this line represents that. So let's do it. So t squared divided by t squared, right, plus 2t divided by t squared, right, minus 1 divided by t squared. Basically this is you simplifying, guys. Okay, do not forget this is dt, and this time around we are integrating in terms of t, not x. Usually it's x, but this time around it's t. So from here we're still simplifying, so the sigma also still remains here. So let's continue, let's do it. So t squared divided by t squared, the first term is going to be 1, and then we have 2t divided by t squared, that is going to give us 2 over t. Remember the exponents. And then the last term here, there's nothing we can do, we just write it as it is, guys, right? It's already simplified. All right, so when it's like this, it's time for us to simplify again. As you can see, the last term here, we cannot integrate the last term like this. The second term can be integrated, the first term can be integrated. So let's simplify this further. All right, so the limit it's 2 and is 3 and 2. So let's continue, guys. Let's do this. So these ones are fine now, first term and second term, but the last term we need to take this t squared on the denominator and put it as a numerator. So we know that when you take the base on the denominator and make it a numerator, the sign of the exponent changes, right, from positive to negative. If it was negative, it was going to be positive, so dt. Right, so this is now we can able to integrate this. Now this, in order for you to integrate this problem inside here, you need to know each and every term. Which rule are you going to use to integrate here? The first one here, it's more like a constant, so we're going to use the power rule. Just in case you don't remember the power rule, I will show you here. The second one, we're going to use the natural log rule, and the third one also going to use the power rule. So let me show you the power rules here, just to jog your memory. The power rule, guys, it goes like this. When you have something like this, x to the power of n, when you integrate this, it's gonna be x to the power of n plus 1 divided by n plus 1 plus c. But this time around we don't include c because these are definite integrals, so leave that c. Right, again, if you don't understand why we don't really have c, it's because you can go and watch the video on the description when I introduce the definite integral. I explained exactly where is that seen. Alright, so let's continue here. So this is the power rule, so we're gonna use this formula here to integrate. Alright, let's do it. So when you integrate, it's better to equate this with y. You can equate it with anything but y, it's very familiar. So when it's like this, I usually say to you guys, you multiply by the variable we are integrating with. This time around it's t, so it's just going to be 1 multiplied by t. So this is going to be t. Right, so let's go to the second one. The second term here, guys, we use this law here. Right, we have k over x dx. When we integrate this, this is going to be k multiplied by natural log x. Right, so this here, guys, this here is the one that we use here. I did explain this law. There is a video on the description. Go and watch that video on the description or on the icon that pops out on our right corner there. Go and watch that video. It explains it way much better here, guys. Right, just in case you don't remember that one. So let's continue. Let's integrate. All right, plus now when you look at kk is 2 here, and then natural log, then what, t. And then this one is the power rule. As you can see, you have t to the power of -2. So this is the power rule. So the power rule is very straightforward. It's -2 plus t to the power of -2 divided by t to the power of -2 plus 1 divided by -2 plus 1. Then from here, guys, what you do is you write the upper limit here, which is 3, and the lower limit here, which is 2. Again, if you don't understand, go and watch the introduction of definite integrals. All right, so let me just erase this part here. I don't want it to confuse us. Now let's continue. Let's simplify this one further. I know it might take us time, but we need to make sure that everything is visible here. We can see what is t to the power of -2 plus 1. So this is going to be -2 plus 1 is going to be t to the power of -1. But then here, what is -2 plus 1? It's going to be -1, right? All right, so this negative and negative, it's going to give you positive by t to the power of t to the power of -1 divided by 1 is going to be t to the power of -1. Now we have our upper limit and the lower limit. Let's continue with our first bracket. So the first bracket, we rewrite this integral here as it is, but this time around on this integral there will be the upper limit only. And then the second step, we also want to rewrite, but this time around we subtract with the same integral of the lower limit, right? Okay, plus 2 and t from here. What we do, we substitute. So it's time for us to substitute. So let me just create a little bit of space here. From here, what we do, we substitute. So the first bracket we substitute with the upper limit, and the second bracket we substitute with the lower limit. All right, let's do this. Okay, wherever there is t, we put the upper limit here. So it's going to be 3 plus 2 natural log 3 plus 3 to the power of -1, right, minus. And then we do the same thing on the second bracket. We substitute with the lower limit, which is 2, right? So it's going to be 2 plus 2 natural log 2 plus 2 to the power of -1, and that's it. From here, you put this on your calculator and then you get the answer. So our answer is going to be 1,644. So basically, guys, this is our answer. Let me just zoom it down so that you can see everything here. So this is how you do this definite integral, guys. Right? If it so happen that you didn't understand somewhere, you can rewatch this video, or you can pause and go to the point where you didn't understand and rewatch it. But if it did help you, you can like this video, share this video to your friends, and also if you haven't subscribed, subscribe to the channel. And at the end of this video, there will be a playlist of other videos that I've done. Go and watch those videos. You can also go to the playlist of this channel and watch videos there. Thank you very much, guys, for watching. Till next time, cheers.